that is exactly. So matplotlib is not like a part of all the standard libraries which come by default in the Python, right? So there are several toolkits available in this Python matplotlib functionalities where you come with the base map, Car2P, Excel tools, mplot 3D, and nat 3D, nat grids, and all kind of that. So you go up with it. So if you just make it a simply thing that this is a uh, plotting tool in your Python language. Okay. So how many kind of plottings are there, right? You have bar plots, you have histograms, you have scatter plottings, you have area plots, you have pie plots. Okay. So you have plots in various kinds actually. All right. So we'll quickly see up like how we can just plot our data in the matplotlib. Okay. And we'll then go with the NumPy part. So let's say this is your x, which is having 1, 2, 3. Similarly, this is y equals to 4, 5, 1. Now let's say we just want to plot this. So we'll be plotting x and y, but before that we'll have to import this matplotlib. Right? And we'll just plot it there. So we'll get this one. Right? That is a basically a graph of this 1, 2, 3 versus this 4, 5, 1. Right? So how to see where is 1, where is 4 and all these things. So in that case, we can mention it, right? That is x and y in some yellow dots. So in this case, you can find up all the points, that is, this is y, or this is 1, or this is 4, 2, or 5, or 3, or like contents. Okay, I think this is clear, right? With this, you can find up things over there. Now, similarly, if we just don't plot this directly, just let's see with this content, we can find all the dots, that is the scatter plottings. Okay, so we'll go up in this matplotlib section after we complete the numpy. Right now, if we talk about the numpy, so numpy is a Python package which stands for numerical Python, right? So this is a core library for scientific computing, which is a very powerful n-dimensional array object, right? So why we use this numpy and where are we used? Okay, so this provides you an interactive tool for C, C++, JSON files and all, right? So it is also used in linear algebra, random number capabilities and all. Okay, fine. So very first thing is like you have to first import the numpy as np. Let me run this. Okay, so this is the first thing we do, right? Now, what is a numpy array? In this numpy, we'll be going up with the numpy arrays. So numpy arrays are the powerful n-dimensional array object, which is in the form of rows and the columns. And here you can initialize your numpy arrays with the nested Python list and you can even access all the elements there like you do in the list. Right? It's very pretty similar to the kind of things you do in the list. Okay. So in today's, we'll be also seeing that if you want to calculate some mathematics section, how you can go up with those things, how you want to, if you just want to plot up those things, how you can just go with that, right? So we'll be going up with those things also. Okay. Now, once you have imported this numpy, like once you have done with the array parts and all, so now we are going to create some arrays, right? That is, let's say this is A and this is to be np dot array. So we see the dimension of this array, that is one dimension, right? So you can easily find out the things with the brackets. Like if it is one bracket over there in the starting, that is particularly your one dimension, right? If it is two brackets, then two dimensions, right? Easy things, okay? Not to be must with a, okay? So these are the basic. One bracket, one dimension. Similarly, let's say this is an array x and this is np dot array. 1, 2, 3, 3, 4, 5, 6, 7, 8. So see the number of dimensions you're having this, right? And what is the data type of this one? That is D type. So you'll be getting, and even you can see for the data type names too. That is integer of 64 bytes. Now what are the item size you're having here? So that is 8 bits, right? And what are the size exactly of this array? That is total number of elements present is 9. Okay, that is how we do, right? So in Numpy particularly, we make it more use as compared to the list, right? Because it saves much time in doing some operations. It also saves time in storing the values, right? Okay. Now we just try to understand, like if I have written an x and I am seeing that the number of dimensions is 2, then what is its shape? This is 3 by 3. Cool. So 3 by 3 means that we are having 3 rows and 3 columns. Understood? 3 rows and 3 of the columns. So that is fine. 3 rows, 3 columns. Now let's say if I make an array of y dot shape. Now what you'll find here is 2 cross, nothing else, right? That is 2 cross. So there is no particular linearity in the elements over there. Then you'll get a same shape like this. Let's say this is 3. You get 2 cross 3 now, right? So there is some sort of linearity in this data now, right? They're having 2 rows and 3 of the columns. Okay. Now let's say you want to reshape this. If you see your y, this could be 1, 2, 3, 3, 4, 4, right? Now in case if you just say you want to reshape this in some different attributes, 3 by 2, so you'll get something like this. Okay, so data would be represented. The data will be represented by the 1, 2, 3, 3, 4, 4. Nice, right? This is something on a reshape. When you change the number of rows and the columns with a given new view to your object. Okay. Now let's say if we just quickly want to see just how to represent the numbers and all, right? If you just want to see how to present up all the numbers and how to go up with those contents. So what we can do with that, right? Like if you want to solve a mathematics problems with the help of a linear equation, in the like you want to just represent some mathematical equations in this Jupyter notebook. So what you can do in that case, right? Okay. So let's just say this is I'm importing Sympy. Or let's say from this importing all the modules. Okay, now guys, let's say I'm having a number 1.3. Okay, and that is being printed up there, right? That is being printed up there. But what if I write it as FOL float, and if I write it as 1.33333 and I give it by 2, just run this, still I'm getting 1.3. Why? Because like I have written up a number which is like non-terminating over there, and there we have written it to be 2, right? So that you'll be only getting one float value, or you can say the total number of outcomes you'll be getting is, or the total numbers you can see in your outcome is 2. So you're getting up there. Now if you write up 3, see the difference, right? Okay, so that is how. Now let's say I have this 1.3 and I want this to be a rational. Let's say I want to just present this 2 by 4 in kind of a rational representation. This 2 by 4, that is 0.5, right? So if I write rational of 2, 0.5, so I'll get to be 1 by 2. That is 2 by 4 is actually equals to 1 by 2, right? We just see on for that. So 0.5 is 1 by 2, right? Similarly, if we just want to say that I actually want to get this as 2 by 4, we want 0.5, and I'll be limiting my denominator. So limiting the denominator to be 100. So still you'll be getting up to be 1 by 2. Okay. So these are some of the kind, like if you want. Now, but let's say this is 1 by 2, right? But I want 2 by 4 only, right? I want this 2 by 4 to be presented, right? So there I can use string methods again, right? But how? Let's say this is my x, which is a rational of 2 by 4, right? If I see my x, this would be 1 by 2, right? But in case if I say that my numerator, what is being presented should be, in case, let's say this to be this, okay, and let's give a denominator. You can use the format method, right? And the format you can write up that you want the x dot p, and write exactly what is the fractional value of this, what is the format of writing any fractional value in the form of p by q, right? So you can write x dot p and x dot q, and when you run this, you'll see numerator and the denominator to be 1 and 2, right? Okay, so that is how. Let's say this to be 3 and 5. So 3 by 5. Similarly as 3. Let's see your x. Okay, this is small x. 3 by 5. Right? Alright. So similarly, you can change anything in a half, anything in a nan value, or anything in an infinite values. Right? Okay. I think you might have got all these concepts of. Okay. So for a very simpler representation, you can specify your denominator limitations, and you can even find out those things. Okay. Now, let's say when we learn Python, like if we want to convert 34.5 in integer, what we do is we apply int and we write this and run this. You'll get 34, right? But what if I write as integer itself of 32.5? Still I'm getting 32, right? So these are some of the calculation part of the mathematics, right? If I just say that I want s dot 1, so I'll get 1 over there. Similarly, s dot 0, 0. Now what is infinite, right? We know what is infinity and all, but how to represent infinity? And that is basically infinity. So if I just zoom it, you can see the infinity sign over there, right? So this is how it comes. If I say s dot half value, so you get half immediately, right? Like if you just say we want some nan values over there, you can even get, okay, in small attribute registry from this. All right. Okay. So see, there is some errors. Cool. So it is man. Okay. So man is particularly called as not a number. Okay. These are not any numbers over there. Now, in the complex, we have learned about the real part and the imaginary part. Let's say this is your x, and this is 45 minus 70, a complex number, right? If we just see the real part of this, that is 45.0. And what is the imaginary part of this? That is minus 7.0. Exactly, right? So these are the real and imaginary part of a complex number. Now, if I say, what is exactly a real number or a real part of the imaginary part of this? That is exactly the under root of minus 1, right? That is iota. So how to represent this iota? That is imaginary unit. That is your iota. Understood? So if you find the square root of this iota, I'll find it to be minus 1. How? Let's say if I write I equals SQ RT of minus 1. And if I say I multiplied by I, right? So I is equal to square root of minus 1. Now, square root of minus 1 is exactly equals to the imaginary unit, right? And run this I multiplied by I. That you will get the minus 1 value, right? So the square root of minus 1 is this I. Even if you run this, you will get minus 1. This is how the basic things you can do with the help of mathematics, right? So you can even form an equation like kind of that. Now, how we can form an equation? There many times students have confusions in that too, right? So let's say you are writing some x as, let's say this to be a symbol x, and let's say this to be y. Okay. So it's let it be symbols then. If it is not taking, fine, done. So you can take x, y as to be the symbols, right? Now what is x? That is x. And what is y? This is y. If you see, it is kind of actually you see in your mathematics books and all, right? Okay. Now we'll just say I want to represent x plus y whole square, right? So how will I write this? So I can write it to be that my expression is x plus y whole square. Now what is the LHS? If I just see LHS. So what is LHS? That is x plus y whole square. Right? That is x plus y whole square. Now what should be my RHS? It should be x square plus y square plus 2ab. Okay, sorry, we do xy. So see your RHS, and you'll find it to be x square plus 2x square plus y square. Now you can evenly put all the values of there and you can calculate up the things, right? So this is how you can make any equation up there. Alright, fine. So you can even find a sine of anything or a cos of anything, right? So that is to be there. If you write it to be x and y, and let's say again in this kind you are taking it to be, let's say if I say from this so you can import the sine, theta, the cos and all those things, right? can import this theta beta. Look, let's just bring this theta and this beta. Cannot import this theta from Sympy. Alright. So let ABC down. So now let's say what is this actually theta? This is a theta, right? And what is beta? This is beta looks like. So basically a mathematical module over there to make you learn how this mathematical things goes on in the programming sectors. Okay, understood. So you can even do some calculation with it. Okay, so let's just say if you're writing it to be a sine of let it to be x equals this. You see, this is your x and this is your y. Now if you write sine of x squared plus cos of x square. What is the value? Sine square x plus cos square x. That is sine square theta plus cos square theta. Right? The expression you are getting up there like that. Right? So you can even like if it is this is an expression for you, like let's say this is an x. So if it is this is an expression for you guys, you can even substitute the values even, right? You can write x dot the substitute value, right? And substitute it the x or substitute the like this is x, yeah. So substitute the x by y. So in that case, you'll be getting sine square beta plus cos square beta and that. Okay. So some sort of mathematical calculations, even you can perform this, even you can perform some differentiation, the derivatives, the integration and those things. You can even perform those high level computations too. Like that is also very easy in terms of terms of you can say coding area, right? Now how those things are done, let's say want to see a derivative. Okay. Let's say this is simples and so you can just define it by, let's say you want a differentiation of any particular expression and the value. So let's say your expression is ex and you want to do with x. So you can see the differentiation to be 0. Why? Because this is a differentiation of a constant, right? So let's just say that if I'm taking it to be expression and I'm making it as x multiplied by the sine of x into x plus 1, right? If I see my x, so I'll get it to be theta sine theta square plus 1, right? Exactly like that. Now, if I find this differentiation of this expression with reference to this x, so I'll see it to be 0, right? What if I say it to be with the reference of this theta? Right? Okay, I think this is x. So you can find it to be 2 theta square cos theta square plus sine theta square. That is exactly the differential value when you differentiate this, right? So that I'm saying that you can even find the differentiation or you can even find the integration of any particular equation in this, right? Let's say you want to differentiate this expression, right? and you want to differentiate this square by 2 or like by x. So differentiation of exponentiation value of x squared by x. So what you'll get is 2 theta e theta square, right? That is how this things goes on. That is how this expression and all these differentiation things go, right? So differentiation of a particular constant is always 0. We all know, right? Right? So let's just say from this Sympy, we are going to, okay, let this to be an ABC. We are going to import this differentiation, the sign. Okay, let us say to be x and y. All right. So this is x and y. Now let's say my expressions to be this say, or else if I just even change my expressions, if I just say that I want to differentiate, so differentiate this x raised to the power of 4 with the x and the 3, so I'll get 24x, right? So if you guys remember the differentiation methods and all, you might be seeing it how these things are worked on. So let's say if I make an expression of x multiplied by sine and 1. This is my expression. So if I see my x, this would be x sine x square plus 1. Right? So what is the differentiation of this? Expression dot differentiate this with respect to x. So this is the differentiation. Right? But what is the derivative of this? So if I find the derivative, the derivative of this ex would be d by dx of x sine x square plus 1. Okay. So that is all how you find out the things, right? Even you can make the simplifications, or even you can just simplify up the things. Alright. You can find the factors, and a lot of things are there. What you can do with this field of mathematics sector with the help of some data science, right? So you can do a lot of things. Okay. Now coming up with the Numpy part again. So we'll be seeing all about the data only. Okay. So what is the data distribution, right? What are the random things and what are the data distribution? So let's just say you are taking from this Numpy, when I import this random module, right? And when you are saying this random dot rand of 10, so here you will get some 10 random numbers, right? Some 10 of the random numbers. Instead, if you write even the 100, still you will get some numbers, and always you will see this to be between some 0 to 1, right? Fine. Now these are some of the random values you can see starting from the zeros, right? But in case, guys, if we just write it's to be random dot random of 100, what is the change, right? These are some of the random values, and these are some of the random numbers you will be getting up, right? Here you will be always getting between 0 to 1, but in this case you will be getting any of the random numbers. Let it be from the negative, let it be from the positives, and like, okay. So what we'll do is we'll reshape this. Since this is 100, I will reshape this 10 by 10. And you can see now there is 10 rows and 10 columns. As reference to this, you can see there are 10 rows and 10 columns now. Right? Okay, cool. Similarly, if we don't want to print the random numbers, right? If we don't want to print up all the random numbers, what we can do is we can write up random dot choice. Now here you can write your own choice things, right? You can write up your own numbers to be printed up. Let's say you only want 1 and 2. So give the percentage what you want, like 0.5 or 0.6 or 0.4, the ratio, and the size you define has to be 50. Run this. Now here you will get 50 numbers, right? But the 50 numbers will be only consisting of 1 and 2. And also in the ratio, like 1 will be presented for 60 times and for the 2 will be presented for 40%. Okay. That is how it will be done up. Alright. So I think it should be clear to you. Alright. Fine. Now, coming up next. Similarly, you can increase the percent, you can decrease the percent. Let's say you have given 0.0. So you will not get anything, right? You will get the probabilities do not sum to be 0. Or like 0.0. It's not done with that, right? You can even take 0.1. That is possible, right? So 0.4 and 0.1. So you'll have to change it to be, let's say you will have totally give it as 1.0. And then you can give it 0.0 and you can run this. So in that case, so every time the probabilities you will be giving there, the percentage of the probabilities you can say will be giving up there, it should be always 1.0, right? So once you have given 1.0, like the total probabilities comes to be 1.0, then it's okay. If it is not like that, then it will raise some errors to you, okay? So in this case, you can see only 2 has been printed. Why? Because in the only 2 we have given 1.0 and this is completely 0. So let's say even if I write 0.9% and this to be 0.1, so it should be totally changed, right? You can see the 2 as 0.1, that is 1%, and all these 1% of 50 is 2, right? If you just want to find 1% of 50, you can even do some of the calculations with that, right? So let's say that if we just want pi r square. So how to represent pi r square? This is your pi r square. Okay. This is a pi x square. So this is how it looks, pi x square. Right? Okay. So these are actually the mathematical representations of your data sets or the data you can perform on. Okay. Alright, moving up. Now let's just say in the data distribution part you have seen, right? But let's say you want the LCM of all these 1 and 2, right? Let this to be a S, and you have printed this S, and you want an LCM of this thing. Now LCM in this thing is like you just want LCM and np.lcm of, let's say, 2 and 4. So the LCM of 2 and 4 would be 4. Now what if I want to find the LCM of all those things? So in that case I can find LCM dot reduce, and then you can write up the array name what you want. This to be M. Yes. So you can find the LCM of this 2 and 1 to be 2. Write that. Okay. This is one of the very important thing like when dealing up with the arrays. Okay. Fine. Similarly, you can find the HCFs and all. That is also same. Right? Okay. Moving on. As I said, like you can perform the differentiation. Similarly, in the way you can even perform the integration part. Right? Now in the integration part is also easy actually. Okay, but before that we'll complete up the numpy, right? Now let's say guys, if you want to find a range of numbers inside this numpy, you can use this arrange. So let's say you want 300. So you can find a range of 300 and you'll get some 300 numbers over there, starting from 0 to 299, right? So how to represent this integration and all those things? Let's say, let's say you want an integral. If you remember up all these things, let's say you want an integral of log x, and you say log x square, and with respect to x. So integral of log x square with the dx will look something like this, right? So like that. Okay, so let's just say this is an expression and this is your dx. So you'll get the values of there. Now let's say if we use do it, right? So do it will give you the integration of this and will give you the value, that is x log x square minus 2x log x plus 2x, exactly the integration of those things, right? That is how it is done, right? So you can even take up the things like, if you remember in the trigonometry, we do with like kind of minus infinity to infinite values and all those things, right? Okay, this is how integral happens, and you can see integration happens here, right? So let's just say that there is an expression, let to be ex, and you're writing it to be x squared plus x and plus 1. A very basic expression, right? X squared plus x plus 1. If we go for integrating it, what would be the integration? That is x cubed by 3 plus x squared plus by 2 plus x, right? And with respect to x, if it does. So integrate of this expression with respect to x. Okay, with respect to the x, if we just solve on these things, so we'll get it to be x cubed by 3 plus x square by 2 plus x, like that. But let's say, now if we modify it and if I say it to be sine of x multiplied by the tan of x, right? So what would be the expression? That is sine x tan x, right? Now if in this case, if you just go for integrating this expression with respect to this x, we'll see it to be minus log of sine of x minus 1 by 2 and all these things, right? So these are some of the mathematical cases what you can perform with this Python. Okay, that is actually another domain to work on. These comes actually in the data science fields where you explore of the contents. Okay, moving up. So I think NumPy is very much clear to you, right? So we are not going to explore all those things in the NumPy, but a basic different thing, like. So let's say if we just want to plot a graph with that respect, so let's take it to be arrange. So a range of 0 to 3, and let it be a pi value, and the intervals in the 0.1, and y to be np dot sine of x. Similarly, let's just, if I just plot it x and y, so we'll quickly see a graph, that is a sine graph. Okay, that is exactly a sine graph. Now let's say if we just take up tan, right, plt dot, say z is equals to np dot tan of x, and we plot x versus z, we'll see a tan graph there, right? Okay, the sine versus the tan, right? Okay, now let's say you want to give some labels to your graph. You can use this x label as x-axis. You can get x-axis over there. Similarly, you can use y labels and the titles to get up your graphs over there, right? So these are all what you can do with the use of this Numpy, right? So let's just say that if it is at the set of numbers, let it to be 1, 4, 16, 25, 36, and like that. All right, the syntax error, fine. So 1, 4, 16, 25, and 36 over there, right? Now, these are actually, if you see it very clearly, we have taken some squares of the 1, 2, 4, 5, and 6. So missed the 3 there up. So 9. Fine. Now we just want to find the square root of all these. We'll be using sqrt of v. We're getting up to be 1, 2, 3, 4, 5, 6. That is exactly the square root of all these, right? So similarly, if you want to find the log of all these v, you'll get the log value. And also if you want to find this to the base of the 10, you'll get the log value with the base of the 10, right? So these can be done with the help of this, you can say Numpy, right? Now let's just say, guys, we are having one expression, right? Just say this is an expression, and that is like x squared and z. Okay, so x squared z plus, let's say, 4xyz and also will take up to be 4y squared z. Okay, so this to be the expression, and before that what I'll do is alright. So x, y, and z are particularly the x, y, and z, right? That is the symbols. If you see the expression, it would be x squared z plus 4xyz plus 4y squared z, right? Okay. Now, so this is a particular equation you are getting up there, right? Okay. Now if you want to factorize this, right? If you just want to factorize these things, what we can use is factor. So if we just apply factor of this expression, we'll not have to solve of the things, and this is the factorization of this particular equation, that is z x. And if you also want to find the code of this, you can even write it for math ml code, and you can get it there. That is the code of this one, right? Okay, so this is very clear, I think, right? You can even modify things over there with your own. Okay, moving up. Fine. So this is how you can factorize, right? You can collect, you can even cancel, like if you want to cancel, or if you want to find the trigonometry or power of anything, right? If you want to minimize any trigonometric equation. So let's just say that this is your expression, and this is 2 sine so 2 sine square theta, 2 cos square theta. See your ex, that is 2 sine square x and plus 2 cos square x. That is nice, right? Okay. Now, let's just say if you want to factorize it, can you use this factor over here if you just want to factorize this expression ex and run this? So you'll get 2 and then sine square x plus cos square x. That is the very basic factorization we'll get, right? That's a basic thing. But what if in this case, if we just want to make it as a factorization, right? If you just want, that is like if you just want to factorize in the terms of the trigonometry, what is the value? Sine square x plus cos square x is equals to 1, right? So it should be 2, not as 2 and then sine square x plus cos square x, right? If we just factor it, it should be like that, right? But after factorization, if we just manually solve it, it should be 2, right? But how to get that 2? For that, you have a trigsym that is used to simplify the trigonometric identities. So you can apply this trigsym and you can write this expression over there and you'll get the value is that is 2 in that case. Okay, so that is used to simplify all these trigonometric identities, and you can even find the cosine, the cos, and all those things. Okay, I hope this is clear to you, right? So let's just say there is an expression, and let's say it's to be x to the power of y and to the power of x z y to the power of z. Now run this. So see your expression, that should be x to the power of y, x to the power of z, and y to the power of z. That's it, to be x, y to the power of x, right? I want to find the expression, right? If you want to reduce this expression of x to the power of y, x to the power of z, and y to the power of x, want to just reduce this by combining their bases and exponents, if you say, in that case. So what we can do is we can use this power is a power sim and use this expression. Not defined. Okay. So you can find it to be x of y plus z and the y of x, right? That is, these two bases are same, right? This powers will be added up, y plus z, and you will be getting this to be y of x. Now let it be, if it would be an x of all those things, then you would have got the exact values of those things, right? I think that is to be clear to you guys, right? So let's say if you was just want a factorial of some 5, so that is 120 exactly, right? But you want to represent an expression of factorial of any particular number, right? Let it to be of x or any such things. So factorial of x. So what is your expr? That is x factorial, right? So we just represent this as factorial of this x divided by factorial of this, let's say x minus 1. So this is factorial of x by factorial of x minus 1. That's how it gets to be, right? Basic functionalities of the factorial methods and all, where you can just combine up the things and can solve up these things, right? Similarly, you can use this if you want to find the combinatorial expressions. You can use it as, let's say this is let's say this is a binomial and we are using it to be x plus 1, y plus 1, and let's form a binomial expression x and y. So you can get the x plus 1 and the y plus 1. This is an expression of a binomial one, right? So we write it as a binomial So there are a lot of operations to be operated. Let's say binomial of x plus y, we'll get it to be x and y, right? So a combinatorial form of, you can say. Okay, so that is actually how written up there, right? Basic things. Now, so this is like how you deal up with the numpy, right? And that is, I think it should be clear to you guys. Now moving up, let's just say now we are going up to the matplotlib section, right? And I'll give you some one of two, three graphs to show you how these things are plotted up, right? So you might have seen now how we can just plot up the things over there in the matplotlib. You can quickly use any of these plotting methods and you can just find out the things. Let's say now we'll make a function and we'll plot at something over there. So let this be a function of f of t, and it will be returning you the exponentiation of this minus t multiplied by the cos of if I. So this will be the use of the function. Okay, the separates. Let's write it here. Let's say this is my t1, which is my np dot range of 0.0, 5.0, and the interval of 0.1. Similarly, I'll take t2. That will be a range of 0.0, till 5.0 in the intervals of 0.02, right? Now let's say we are plotting some two graphs, so we'll be using subplot. So 2 to 1. So this is the first plot I'll be using, that is PLT plot. And let's say we are plotting this T1 and the F1. And let's say f of T1. T2, f of T2, right? So blue 0 means, BO means blue colors, right? And the blue dots. Okay. Moving on. So this is the subplot second. So similarly, we'll be plotting up here the T2 versus the cos value of T2, right? And we'll show up the things. Now we'll see a graph, and this is the two graphs up there, right? You can even set up the index and you can even find up the things. So this is how this graph's working, and this is how this Numpy works on, right? So two subplots are there, 2 to 1 and 2 to 2. All right. So you represent it by there, right? That is number of rows, number of columns, and then the thing we are plotting, right? That is number of rows to be 2, right? And number of columns to be 2. And you're plotting the first graph and the second graph like that, right? I think that is very clear to you guys. Okay. Now we're going up to learn about this Pandas, right? The Pandas is very important in the terms of this data science, right? Here actually you deal up with all of the data structures. Okay. All right. So let's just start up there. So Pandas is a package used for data manipulation, analysis, cleaning, wrangling, or you can say even for the analyzing part, right? So Pandas is particularly used for all the data algorithms you are going to do, right? So To import this pandas, you'll just have to write import pandas as pd, and that's it. Run this. You'll get all the things from the pandas. Okay. Now here what you do is actually, remember we were having a Aadhaar info. That is this, right? Here we'll be quickly starting up with the data frame parts. So here you have data frame, which are actually a 2D form, so which make a tabular sheet of that. So let's say we want to make a tabular sheet of this Aadhaar. Run this, so you'll get a tabular sheet. That is, first name is username, his Aadhaar number is this, and his address is this. Second one is the username, his hello, add number this, and the address to be this, something like, right? Similarly, you are having 0 and 1 as the index values here, right? Okay. This is how we deal up the things. Now there is something more interesting that is called as a random number, right? So random numbers can be used to generate some random codes over there. Now let's say this is one of the code, and let's say it to be, okay, first let's import. So let's import the random integer, and let's say this to be code is equals to random integer, right? So random integer, let's give any values over there. Okay, so this is equals to the code. Now we'll just print it that just like this is how it comes. So run this, and you get something like this in your mobile phones, right? That this is your password reset code or something like this from the Googles, or like from the Facebooks, many times from the Instagram and like that. Right? You get these contents. Whenever you run this, you'll get every time a new OTP you can say on, right? So this can be used as for the OTP generations, and every time you can see a new outcome over there, right? So this is one of the important module that is random, and it's very useful in various things. Okay, okay, fine. Now these 0 and 1 are actually the, you can say for that, these are actually the index numbers, right? All right. Now let's just say that random is something like, if we just take, guys, say if I'm saying a random of 20, or random of 20, so something is missing. All right. So what could be here, right? If I'm writing for 20 to 21, so always every time we'll be getting out 20 there, or in the 21 there, right? That is the only value you'll be getting up there, right? So the only difference in the random or the rand range is that, like if you use rand range, then the last value will not be there, right? 1 minus the last value will be there. It is 89, 98 and 73. Up to the values you will be getting up there, right? But if you use randint, you will be getting also the starting value as well as the ending value as the same, right? That is all the random things. All right. Okay. Now let's say, so this can be used for various purposes, right? You have seen now. Okay. Now we'll be doing some data analysis. So let's just we'll be needing some of the data there. So I think there are some of the pretty data sets. Use with the Seaborn, right? So let's say we are going to use a Seaborn. So which will be used basically to plot some graphs. Okay. Done. Right. Now we just load a data set and we'll explore that. Now once our data has been loaded, we'll see it. So this is our data, right? There we are having some sepal length, sepal width, and all these. What is actually this data set of? This is the data set of an flower iris, right? It is having three species, that is setosa, versicolor, and virginica. But we can only see setosa here, right? So how many rows and columns there are in the data set? So that is the shape. So we are having 150 rows and 5 columns. That is great. Right? How many species are there? That is df dot value count. So df of species dot the value count. So we are having 50 species, or you can say 50 occurrence for this virginica, 50 occurrence for this setosa, and 50 occurrence for this versicolor, right? The series name is species, and the data type used is the integer 64 bits. We want to just see the count plot, or if you want to see the scatter plot. Just say we'll be looking up for the swarm plot. Right, there are a lot of plottings actually. So let's say we want to see the petal length, and in the second hand we want to see the sepal length. And the data is from this df, and just plot this. So we'll able to see a graph over there, and there it is like this, right? The sepal length versus the petal length, and you can find out these things over there. Okay, that is how exactly. Even if you want to just plot this with a greater, you can say with a greater dimensions, you can use this figure, and here you can use fixed size. Sorry, so you can use 20 by 850 or 10 by 8 would be fine, I think. So you'll get a graph, and this is actually fine if you see up there, right? So kind of graphs you will see up there, right? So this is how actually you deal up with all those datas and all, right? So let's just say that we are making x as a range of elements, that is 1000, some this much numbers. So what is the length of this x? This much. So we just print, we just say that for I in length of this x, print x. So in that case, okay, print I. So int object is not iterables, all right. So in this case, what you'll see is, you'll see all the elements of this x to be printed up there, right? And it will go until it completes its execution. So till whatever range you have given, you'll be getting up the numbers over that range exactly. Okay. So that is like what is range works here, right? Similarly, let's just stop this and interrupt this kernel. Just cut it. Okay. Now let's say I want an arrange of, okay, I don't want to arrange, let's say this is a blank list, right? and we are applying a loop for x in. Now in this time we'll be using np.arrange. So for x in a range of, let's say, this much numbers, right? For x in the range of this much data, what we'll do is we'll take y as np dot, we'll take this y as np dot random, or let's say only with the random randant of 1 2 3 4 5 6 from 9 8 7 6 5 4, like that. Y equals to randant of this, and y will be finally equals to, and there will be a z which will be equals to the str of y plus st g dash, right? So this will be done, and the n, what we'll do, we'll be trying to x dot append this in the cell, right? And let's just take it to be y I. So for I in this range of this one numbers, what will happen? This will go for a range of this all elements, and we'll make a code up there, right? We'll make a 6-digit code and we'll append in this x, right? That is a pretty statement, and we'll do. It'll take some time, so just hold for some minute. It will execute up there. Done, right? So what is the length of this x? 2. So this is like 1/10,000. So there are some 10 lakh codes, right? So there are some of the 10 lakh codes over there, right? So what are the size of this particular x? So let's just make it an array first. So what are the size? That is 10 lakh, right? So we are having 10 lakh items in this C. Now guys, let's say if these are the 10 lakh items, if we just make a date range, right? If we just write pd dot date range. Okay, don't take it to date range first here. Let's just say we are having this much thing. So, all right, and let's say we just see C of first 10. So what you can see is there are some of the codes, and these codes are exactly how you see it in the Google codes, right? This is how exactly this Google codes comes inside your phone, right? I think this is clear, right? This is how exactly you get it, right? So there are some of only the 10 numbers I have printed, right? Some of the 10 codes I have printed. Similarly, there are how many codes? 10 lakh codes we have generated within some seconds of the time, right? We have generated this some 10 lakh Google codes within some of the seconds, right? But what if there is any similarities? Because we know that a random number can be same, right? Because that is machine generated values, and that can be same anytime. If we just say import random, and if I just say random dot rand range of 1 to 10. So anytime there could be any same values, like this is 2, 3, the C again 2 came, right? So 5, maybe 3 could come again, or 2 could come again, see again 2 come, right? So it is like a random value can be regenerated, right? A same value can be find on, right? That is, so that could be an issue, right? That could be an issue, like you can't just go for finding up the same things, right? Because if you are generating 10 lakh data, if you are generating 10 lakh data, how many unique numbers are there, right? How many numbers are there? So let's just say this PD Now I'll have to make it short. Let's say this is PD dot, and just apply this the starting date, whatever the starting date you want. Let's say from 1/1/2020 until what periods you want. So let's say for the first 10 days. So run this. So you'll get a date 1st Jan, 2nd Jan, 3rd Jan, 4th Jan till the 10th January. Alright, like for the date range if you say. Right? Okay. So these are the things.